we go.
Good afternoon. I'm Kevin Corson, Powder Coating Institute's Executive Director. On behalf of PCI, thank you for joining us. Today's webinar is Recent Trends in Chemical Pretreatment, presented by Suresh Patel of BASF Chemetall. Before we get started, I'd like to remind everyone that all attendees are on mute, so if you have any questions along the way, please type them in the Q&A panel. Suresh will address these questions at the end of the webinar. If we run out of time, you will have the opportunity to connect with him through email after the webinar. This webinar is being recorded and will be available through the PCI store within 2 business days. All attendees will receive a brief survey after the webinar. Please take a few moments and reply to the survey. We appreciate your feedback as PCI continues to develop new programs to offer the topics and training you need. Now I'd like to introduce the presenter for today's webinar, Suresh Patel. Suresh has worked for BASF Chemetall for 30 years and is the Director of North America Business Development. He holds a master's degree in chemical engineering from the New Jersey Institute of Technology. He has made numerous presentations to trade organizations and companies, including PCI, the Chemical Coaters Association International, at FabTech, and the Electrocoat Association. He is the current president of the PCI Board of Directors and vice president of the Electrocoat Association National Board of Directors. Suresh, welcome and take it away.
Thank you, Kevin. Thank you, everyone, and thank you, PCI, for this opportunity to present one of my favorite topics, zirconium-based pretreatment. So depend upon where you are, what time zone you are in. Good afternoon, good morning, good evening. Let's get started. As I mentioned, I have been pretty much involved with many associations and organizations and have made numerous presentations for last 10 years on the zirconium-based chemical pretreatment, advanced pretreatment, thin film, and so on and so forth. Since it was born in 2007 and 8, I have learned a lot. I have learned a lot jointly with you guys from the real world. So I think it makes sense for me to share my years of experience, real world experience, rather than reading through word by word, statement by statement, slide by slide. So let's get started on it without further ado. So recent trends, we always talk about recent trends. What does that imply? What does that mean to people like you, me, and rest of the world? Well, you know, as I mentioned in 2007 and 8, that is when it was pretty much born or ready to be born, and call a first generation, then came a second generation, then came a third and a fourth one. And in those, during those first to the second to the last generations, there were variations within the chemistry formulations. Some were applicable only with the zirconium application. Some had some metals included in it, copper and a titanium manganese kind of thing. Some used only in spray washer, some perhaps in the manual side of it. So like I said before, we all have learned a lot, and I'll share that with you. Then we'll also talk about where the applications, where the markets, where the trends are. Are they strictly used in automotive industries or general industries, appliances, AC industries, and so on and so forth? Is it applicable in the manual wand wash to the spray to the immersion line? And as I mentioned before, it's a next generation to the next generation to the final generations. So in the agenda for the next 45 minutes or so that I'm given, I'll be presenting 24 hours worth of content, real world knowledge that not only me, but my friendly competition already has and have developed the formulations throughout the course of last, I would say 12 to 13 years. So in the agenda, what we'll talk about is the conventional pretreatment, i.e. the iron and zinc phosphates, as more of a historical background. What are the recent trends in the zirconium side of it? How that would be applicable to you guys? What's the overview of it? Because you might have heard me in the various associations as well, the benefits and the features and all that stuff that the advanced pretreatment would offer. And from the next generation to the latest one, what are the new formulations? What are the new treatments available in the marketplace? How that is going to be applicable for you now or in the future? And then we will end with the Q&A. So as you are well aware, iron and zinc phosphate pretty much out there for many, many, many years. And I would call as the industry guide, industry standard until recently. Last 12 years, many people are considering going with the zirconium-based pretreatment. Let's call a green pretreatment, let's call a new kid on the block. While the iron and zinc remain as the industry standard, because it does offer a lot of benefits and along with some challenges. So if you look at the iron phosphates, yeah, it's minimal corrosion protections, it's less expensive, less maintenance compared to the zinc phosphate. Zinc phosphate has a high maintenance because of sludge, heavy metals, trication, filtration system, but it does offer excellent performance. But then it's costly as well. So what is the end game here? Are we talking about the automotive standard performance? Are we talking about general industry type performance? Are we talking about indoor protection? Are we talking about outdoor protections? Are we talking about indoor non-critical or critical, outdoor non-critical or critical? So depends upon this specific conventional pretreatment. We can also gear our thought process towards the zirconium-based pretreatments. So as of last, let's call it 12 years to make it easier on us, there are trends in the marketplace. If you remember 2000, right around 2006, 7 and 8, oil price hit 130 plus, north of $130 per barrel. Those who are familiar with the phosphates, if you recall, phosphates price were going exponentially higher. As such, the iron phosphate, as such, the zinc phosphate cost were pretty high during those days. And it started with the European regions, then came to Canada, and now it's pretty much in North America as well. Is the environmental regulations. They wanted to control the cations, which is the zinc-based, zinc, and then some borons and all other heavy regulated metals, plus the phosphate. Phosphates pretty much is the challenge for our environment, for our nature. And as the costs were going up, not only for the raw material or for the chemistry side of it, there were cost relates to the maintenance. If you look at the zinc phosphate, and you will see in the pictures that it does produce a great deal of sludge. And we may perhaps have filtration systems, yet you still have to do a lot of maintenance on a quarterly basis, monthly basis, yearly basis, descaling, and the water treatment cost as well. And last but not least, as you might be hearing, for the last several years also, Ford aluminum F-150. So lightweighting, because people would like to reduce the weight of the vehicle, overall weight of the vehicle, so it increases the efficiency and the mileage for the gasoline side of it. So these days, it's non-ferrous substrate that people are going with. Lightweighting still maintain the corrosion resistance. So these are the recent industry trends and how the zirconium pretreatment will be applicable. Let's move to the next slide to see it. So advanced pretreatment, and I wanted to differentiate that as it is the advanced pretreatment compared to the conventional iron and zinc phosphate. What are they? They are simply the zirconium-based family of pretreatment that would replace the conventional iron and zinc phosphates with considerable operational advantages, as it offers a lot of advantages. Those who are quite familiar with the chrome, many years ago, as I have been with Chemetall for 30 years, many of you guys probably are used to terminology called the chrome seals. Many years ago, chrome seals, final seals after the iron and zinc phosphate, chrome seals were industry standard because of the high performance. At that time, people were reluctant to change. Nobody wanted to go with the non-chrome seals because chrome seals industry standard, high performance, it's not proven. I don't want to take a chance. I don't want to be the first one as a guinea pig. On and on and on and on. That was about 25 years ago. I am proud to say, along with all my friendly competitors, we hardly use any chrome-based seal these days. It's all non-chrome final seals in the post-treatment process. Same thing applies here when we talk about the zirconium-based pretreatment. As it started 12 years ago, and I and many others would be the first one to admit that when it was born back then, there were challenges. I'll be the first one to admit as well. All have gone through that. We have learned a lot since then. Not many OEMs, not many custom coders, they were reluctant to change like from the chrome seal to the non-chrome seal. And as we all have learned together for the last several years, due to our team efforts, I'm proud to say that there are more than 15 million cars on the road running with a zirconium-based pretreatment on the surface. So it's coming. And we and you should be thinking out loud because it does offer a great deal of benefits compared to the conventional pretreatment. There are numerous names out there, and I want to throw it out here for all of you guys to see it. Advanced pretreatment, thin film, inorganic, transitional metals because of zirconium, titanium, vanadium, organic silane portions there. Thin film, I think, is more commonly used. And some others name that is being given to this type of zirconium pretreatment, I would refrain from using the nano. Nano does not apply here. There is no nanoparticles in zirconium pretreatment whatsoever, at least from my perspective. In the beginning, early days of these formulations, people were used to, and people sometimes call a nanotechnology. There is no such thing as a nanotechnology. And when I say it's a family of products, i.e., everybody would like to make sure that they have some options to use the zirconium pretreatment based on that process, i.e., manual spray wand process, 3-stage, 5-stage, 7-stage, general industry, indoor, non-critical performance to zinc phosphate, outdoor critical performance. You want to make sure that we have a family of products that covers the broad spectrum of the applications, rather than using the one-size-fits-all approach. So I can again reinforce that please do not use nano. Nano was the industry generic name, still is the generic name. It was sort of a misleading, the name that was pretty much used by many people in the past. I don't think so people are using it as much, but still, if somebody would like to sort of encourage you to start using a nanotechnologies, zirconium based, so and so forth, you may want to say that they are not the nano, they are the zirconium based and a thin film pretreatment. That is what my suggestion would be for you guys to use. So family of products, I briefly mentioned to you that high performance, Tesla, General Motors, Ford, in Europe, BMWs, Passat, they are using the high-end zirconium-based pretreatment replacing the zinc phosphate. Then you have the pre-paint zinc phosphate for the automotive components, tier 1, tier 2, tier 3, military application, general industries and other markets. If you are talking about the indoor iron phosphate applications or some outdoor non-critical applications, that's for the typical general industry markets. There is a pre-paint iron phosphate 5-stage, then a 3-stage, dry in place, cleaner coater, rinse. Then there are manual wand washes available, zirconium-based pretreatment for the aluminum side of it. Then for the rubber to metal bonding applications, magnesium, it is being tested as we speak. And for the automotive OEMs, when you have to do the repair of some defective small areas and so on and so forth, like let's call a touch-up repair, the zirconium pretreatment is also available in the market. So as you can see from this specific slide, there's a spectrum of the zirconium-based family of zirconium-based products that is available in the marketplace to fit your specific requirements. So as I mentioned, there are a lot of benefits, and I'll go over that in a detail here, not only in just in terms of only the energy savings and so on and so forth due to the high oil price back then. It's environmentally friendly. As I mentioned, you have no heavy metals, non-regulated heavy metals. Energy savings, it runs at ambient temperature. And in some cases, it runs below ambient temperature, like in Wisconsin in the winter time. 55 Fahrenheit temperatures. We have process running at below the ambient temperature, but we call it ambient temperature or a room temperature 25 degrees Celsius at 75, 77 degrees Fahrenheit. Low water usage. If you design the washer properly or if you modify the existing washer properly, you conserve tremendous amount of water, and you will see in the next slide what are the sort of like a typical savings based on the energies and water that you would realize for a typical zinc phosphate process in the next slide. Low or no sludge, and I'll share some pictures of real world application. After the 6 months, you could see through the bottom of the tank. That's why we call a no or low, virtually no sludge. You just need a little bit of a small filtration system on the pretreatment, zirconium pretreatment, to filter out your ferrous sludge. Fewer stages. If you are talking about a brand new line compared to zinc phosphate, there are less number of stages, and I'll go over that in a detail as well in a minute. And versatile. Versatile, it's applicable for the spray wand, applicable in the spray washers, applicable in the immersion or dip processes. It's applicable for all types of coatings. You talk about powder, liquid, and electrocoat coating. So that's why it's versatile. So typical zinc phosphate, this is based on our own experience that one would realize. On a relative cost of $100 for the zinc phosphate, chemical cost remains the same. Heating, of course, you run at ambient temperature versus 125, 130 Fahrenheit temperature. There's a 30% savings right there. Electrical energies, rinse water, wastewater, maintenance cost, and I would say the lines that are run using our process, and I'm sure our friendly competitors' process, typical savings on an average from a 12% to 18 in some cases. If the line is designed and well robust, people have realized about 20 to 25% of savings in the total cost of operation as well, while maintaining the quality, while achieving the same performance. Regarding the environmentally friendliness, zinc, nickel, manganese, there is federal limits on how much you can let it go to your POTW. Phosphorus, same thing applies here. When you talk about not only in Europe and Canada, phosphorus is pretty much banned out there. And now if you look at some of the Midwest area, some of the Northeast area, phosphorus is pretty much coming to a parts per million level, as you see from this slide. And some pending phosphorus regulations that will be potentially coming in the Chesapeake Bay, Virginia area, some Hudson River, and Chattanooga, Great Lakes, and so on and so forth. So my message again is that it's coming. It's just our mindset. It's just that experience that we all have built over last 12 years on how to run it so that it runs like a champ, like the iron and a zinc phosphate, that what we were used to before, and now we are used to the zirconium-based pretreatment here. With that, let's keep the planet green. As I mentioned to you before, you see on the left side, that's the 6 months old zirconium bath and pretty much no sludge. This is from one of the pretreatment zirconium solutions, ran with the 25 micron filter system. On the right side, those who are running the zinc phosphate process, you guys are very well aware of the heat exchanger pipes and the lines clogged like this one. And as we all know, that we have to descale this pretty much on a weekly or bi-weekly level, the heat exchanger systems, plus the decanting, as well as using the press filter systems. So, and not only that, now you have this cation that you have to deal with, plus the water treatment cost, the maintenance cost, and all that. Whereas by having no or virtually no sludge, you pretty much would like to once every 6 months decant the tank and just pressure rinse it. And you can put the zirconium bath back into the tank, optimize the solution parameters, zirconium levels, the acid levels, and all this, and back in the business. Versatile, spray immersions, roll coater, spray manual wand, multi-metal as well, steel, aluminum. Many processes are run simply just a steel, cold rolled steel, hot rolled steel, mostly in the ACE industries. Some are run using the multi-metal, which is the steel, aluminum, hard dip galvanized, which is a zinc substrate. And multi-paint. So it is applicable or compatible, let's call it compatible, with the powder, liquid, electrocoat, and rubber to metal bonding. So as you can tell, besides the benefits, besides all these savings and so on and so forth it does offer, it is compatible across the board. Let's take a look at some of the comparison on the coding side of it. And you guys can read through, I won't go into the detail. So the physical and characteristics, the process and the performance of it. I'd like to spend a little bit more time on the performance side of it rather than on the some of the coating weights related. The performance side, of course, as you guys well know, iron phosphate, I would say typically from 30-50 to about 70-75 milligram per square foot. Zinc phosphate about 250-300, and zirconium pretreatment, it's a low coating weight because that's why it's called a thin film. It does not do as much of an etching that iron phosphate and zinc phosphate does. That's why it does not produce as much of a sludge or virtually no sludge. Talk about the performance. If you compare your zinc phosphate or iron phosphate performance, and you guys familiar with the neutral salt spray, you guys familiar with the cyclic corrosion testing, and as an example, if we look at, let's say, 1004 hours neutral salt spray comparative testing we are doing with the iron phosphate and now comparative to the zirconium pretreatment, as you're well aware, there is the creepage from the scribe. There is always a range. Always a range, 1.5 millimeter to 2 millimeter. Range is 7 to 9 on the mean and max. And out of 10, that is what I'm looking for. If the zirconium pretreatment that you are replacing the iron phosphate with is within that range, the performance are met. But most, if not quite many times, that during the audit process, when we pose this question to our customers and prospects, I'm afraid we have not established that performance level. If we have established the performance level, we might have done it when the washer was new. We might have done it when we started the process with pre-treatment and the coatings at that time. Let's say it's a powder coating from ABC company. Well, since then, if there is a coatings change, if you have changed from A supplier to B supplier, the performance has changed. And often when we ask this question, we run into a challenge, and my observation suggests that we need to improve upon that side of it. We need to establish the frequency. We need to establish some guideline. Should we do it for every 6 months? Should we do it every time when we change the paint supplier? Every time when you change from conventional pretreatment to zirconium pretreatment, every time you change from supplier A to supplier B, there should be some guideline to either do the neutral salt spray or cyclic corrosion testing, whatever the performance requirement that you have to match. If you are OEM or if you are custom coder, you know your customer's requirements and you have to accomplish that accordingly. Again, conventional versus the advanced pretreatment. I won't go into the details. You guys can see on the slide. Significant difference in the coating weights, as that's why there's less sludge. The key focus is ambient temperature, sludge very minimal, and performance equal or better. Equal or better from the hundreds of lines that is running using the zirconium pretreatment in the marketplace. Less number of stages I mentioned. As you see in a zinc phosphate, pretty much you have a zinc phosphate. Prior to the zinc phosphate, you have a conditioner stage, and in the post-treatment, you have the final seal stage. So after the cleaner, you have 3 additional stages. If you go with the zirconium pretreatment, there is no need for final seal. So you talk about only 2 chemical steps, cleaner as well as the zirconium pretreatment, versus potentially 4 in a zinc phosphate, which is the cleaner, conditioner, which is a grain refiner, zinc phosphate, and final seal. If you are replacing the iron phosphate typically it's a cleaner, iron phosphate, and final seal. Instead of 3 chemical stages, you will be going with only 2, cleaner and the zirconium pretreatment. System requirements. Unless you hear otherwise, Next few slides, I would like to really share some, again, real world examples here. You could very well go with the polypropylene tanks. It's compatible with the zirconium pretreatment. Our recommendation is stainless steel. I have not seen anyone using polypropylene. They might be using for the plexiglass kind of to see through where the risers are and whatnot, but the tanks are made out of stainless steel because of the sturdiness, because of the ruggedness, because of the longevity of it. Do we have to have stainless steel across the line, which is starting from the cleaner all the way to the post treatment final stage? Not necessarily. The recommendations to go with the stainless steel is it's important that we would use the stainless steel rinse prior to the zirconium pretreatment, and all the following rinses after that. Has to be stainless steel. Very good water quality. When I say very good water quality, you talk about less than 100 ppm, less than 25 ppm of a chloride sulfate. DI RO is preferred. Do you have to use DI systems? I won't say that. I won't suggest it. If you can go with RO water, 25 to 50 micron, it's perfectly fine. Excellent cleaning. I have reinforced that during my many talks for the last several years at various associations. Excellent cleaning, excellent cleaning, excellent cleaning. There is absolutely no ifs and buts about it. Remember, as I mentioned, in the iron phosphate, you have cleaner iron phosphate. In most cases, it's the iron phosphate cleaner coater, followed by the post rinse and a seal. Same thing, zinc phosphate, you have cleaner zinc phosphate and the final seal. Both iron and zinc phosphate, strong acids, zirconium, wicker acid. That's why it does not etch enough. In a cleaner coater version with iron phosphate, if you compromise a little bit of a cleaning in your cleaner stage, iron phosphate will help with the extra cleaning. Zinc phosphate will help with the extra etching. That is not the case with the zirconium pretreatment whatsoever. So there is no ifs and buts about it. You have got to clean the parts quite well. Same thing applies with the rinsing. Excellent rinsing between the stages. And if you don't rinse the parts well, you might as well forget about what you are about to apply, which is a zirconium pretreatment. And as to why? Well, because if the rinse water conductivity is higher, if you are dragging a lot of alkalinity from the cleaner stage into the zirconium pretreatment stage, I'm afraid you will drop the active ingredient, which is a zirconium, in your pretreatment stage, and it's coming in the next slide. That said, how do you successfully transition, or how do you successfully come up with a new pretreatment line that can be used with the zirconium pretreatment? People would very well like to start with the conventional pretreatment, but they would like to have a flexibility to switch to a zirconium pretreatment few months after the process is up and running. So when you are transitioning from your conventional phosphate existing line or a new line, there are ways to do that. And those who are running it, they are running it quite successfully because we have learned a lot. We are teaming up together with the pretreatment suppliers, with the coating suppliers, with the washers manufacturers, and doing the due diligence necessarily. And if we do that, then there is a successful transitions, and I'll walk you through those steps basically. Qualify the process. Anytime when you talk about a zirconium, You have to make sure that you're qualifying the process. You want to make sure that there is baseline created, baseline of iron phosphate or your current process or your current requirements. Qualifying the process, I'll reinforce the word also that I have said many times in the past. They are not the drop-in replacement. People may think that, oh yeah, it's iron phosphate. It's a phosphate, non-phosphorus. It's okay. I could just drop in and I can have the zirconium run the miracle for me and the process, and I can take care of it from that point on. It's nearly impossible for us to manage it that way. It's not a drop-in replacement whatsoever. Qualify the process. Changing from a phosphate to a non-phosphate. From a phosphate to a non-phosphate. We did not change anything, to be honest. Your system's configurations remain the same, limitations, the soils, the substrates, acid peakle states, part size, shape, other elements. We all have to consider that. There is an impact on it, as I mentioned before, the cleaning side of it, the rinsing side of it. Qualify the process using the survey. Am I going to have the same kind of soils? Am I going to bring any other soils? Bring any soils with the substrate, bring any soils, incorporating the soils during the fabrication process. What kind of water quality I have, what kind of water quantity I have, what are my limitations, what kind of coatings I will be using. As you see on the top right corner, pretty much this is the challenge that I ran into back 10 years ago. Customer mandated that they want to go with the zirconium pretreatment. And I'm sorry to say that, learn a lot. When you have a drag out, what you see on the top right corner, when you see that kind of drag out from one stage to another stage, you might as well not compromise with your conventional pretreatment. It just simply will not work. Unless you make a tremendous amount of process modifications, it will not work. Cleaning, I said enough. Advanced pretreatment, it does not provide enough cleaning and etching compared to your conventional pretreatment. No compromise whatsoever. No compromise whatsoever. It has to be cleaned well. Excellent rinsing. Not a drop-in replacement. Phosphorus from the cleaner stage. Some complexant additives from the cleaners. Drags out. Alkalinity dragging out. Precipitate the zirconium. Contamination in general. So there are ways to conserve the water. There are ways to counterflow the water from the last stage to the first stage. But you have to make sure that we are rinsing the parts in between. And that's an essential step in the entire process as well. Here are the pros and cons, which I talked enough: multi-metal, long bath life, fewer stages, ambient temperature. So I won't rehash that. But as you see, it does offer a lot of benefits. And if we do it properly, it does work. My favorite slide that I always reinforce during my talk: due diligence, due diligence, due diligence. Form a team. Communicate, communicate, communicate. Enough said. You have to bring all the parties responsible to help you run the process or help you design the new line with your equipment supplier, coating suppliers, pretreatment suppliers, and you guys included. Plan it out. Ask those challenging questions. Ask those probing questions upfront so that there is no surprise at the end of the whole process. And when we are ready to run it, we run into the challenge. Performance requirements, as I mentioned before, want to make sure that you have some sort of a baseline created. Often we overlook that part. And then at the end of the 11th hour, we try to scratch the head and say, gee, I don't know that. You talk to the paint suppliers. Their page number 2, technical information, always have some sort of either a neutral salt spray or a cyclic corrosion test data with bond right panels. That's the guideline. Any pretreatment suppliers can certainly do the testing, design of experiment we call DOE, to come up with the baseline for the performance side of it. It's important that we do this and carefully plan out before we think about either transitioning or coming up with the new line to be used with the zirconium pretreatment. So coming back to my main slide here, in the last 12 years, anywhere from a high-end automotive OEMs, the cars, to the auto components, all the way down to the manual one was process. There's a broad family of zirconium pretreatments available in the marketplace that can cover the spectrum of the industries, and it's out there. By doing proper due diligence, you as well can run the zirconium process effectively. You as well can transition from your conventional pretreatment to zirconium pretreatment effectively and efficiently. I mentioned to you for the automotive approved, there are touch-up manual wipes also available that can be applicable in the general industry as well. So that's something you could keep it in your mind should you need to rework some of your defective areas. There are touch-up manual wipes available. I'll run through the slides as I have spoken quite a bit about where it is being used and can be used. Advanced pretreatments found in the car production, over 15 million cars already on the road utilizing zirconium pretreatment. It's not only for the car bodies, for automotive components as well. Not only for the automotive components, but it's been used in the ACE industries, appliance, snowmobile, furniture, and other general industry market. Catch the green wave. You don't want to get left behind. Like your and my other OEMs and custom coders have already started realizing. It's a mindset. Many years ago, we were reluctant to change from chrome seal to non-chrome seals. They have effectively changed. And last 12 years, OEMs and custom coders also started changing from the conventional phosphates, iron and zinc phosphate, to the zirconium pretreatment very effectively. In summary, while it offers cost savings and other benefits that I reviewed in the slides, please keep that in mind. It is not a drop-in replacement. I also often have said it is not the cup of tea for everyone. When I say it is not the cup of tea for everyone, I meant it's important that we all know what we plan to do with our due diligence, with the qualifications of the process, the challenges, the limitations, and then outlining, considering all those important factors that I mentioned before, and doing a thorough due diligence, we can make it happen, since we all have learned a lot for the last 12 years. We are in it together to win it together, and we have done so. With that, Kevin, I'll open up for any questions. It's 2:45. Kevin?
Let me see if I can get it back. There
Okay.
it is.
All right.
All right. We do have some questions here, so we'll run through them. And not long dissertations, but just some quick answers, and you can take it in offline if you need to later. First is there zirconium pretreatment being used for pipe coating?
No, not at this point in time. It has not been tested with the epoxy fusion coating as of yet. That is something I'm sure, including us, many of my friends are also probably considering testing it. But to answer that question, not at this point in time. I don't have any definite test data.
Okay. What level of filtration does zirconium require?
When you say what level of filtration, can someone elaborate that question for me? Are
It's
they talking
probably how many, what micron bag or filter do you need?
We recommend 25 micron filter bag, cartridge filter system. And Kevin and the audience here, we have not used larger filtration systems at all. It's a small, I would say size 2, which I think is 8 diameter by 32 inches, a small size 25 micron filtration system just to remove the ferric sludge. If you are running all steel or multi-metal applications, that's what we will run it. And as you see in the picture, that was running the 25 micron filtration system.
All right. In the photo in there, you had for the 6 months clean solution for the zirconium. What's the raw material, steel or aluminum or mixed that was going through that process?
If I recall, this was all steel.
Okay.
This was for the ACE Industries.
All right. What is an example of metal to rubber adhesion process? Where is this process used?
Okay, metal to rubber is primarily used in the automotive components. As you might have seen some components where what they would do is they would pretty much have to make sure that the high temperature rubber, mostly silicone based, stick to the pre-treated substrate, which is the steel, in some cases aluminum as well, that bonds to the substrate. And that is where there is not the zirconium, but zirconium derivative pretreatment is being used for the rubber to metal bonding. If I refer some names here, because this is non-commercial presentations, but it's a customer or let's call a prospect or used in the automotive industries, Lords Corporations, they do a lot of automotive components, rubber to metal bonding for where they have to apply the let's call it gaskets in the engines as well, where they have to have rubber to metal bonding between the two substrates.
Okay. How many rinse stages are recommended before and after the zirconium stage?
Excellent question. Excellent question. So you can have one stage or you can have two stages. It depends again upon the size and the shape of your substrate. Depends upon how much potential drag out you may very well have. Depends upon whether you would have acid pickle stage between the cleaner as well as the zirconium pretreatment stage. Okay. So, I mean, in a simple way, if you don't have a drag out or a very minimal drag out, you may consider using one very good RO water prior to the zirconium pretreatment, and then you can have misting nozzles pretty much misting nozzles just prior to the parts going into the zirconium pretreatment, and you can counterflow that water into that rinse stage that goes back into the previous stages. If you have acid pickle stage, minimum 2 rinse stages are required because you have to neutralize the surface prior to going into the zirconium. Otherwise, you will have the flash versus situation.
All right. Cleaning before the pretreatment is already a challenge for the industry. Are there any plans to develop zirconium pretreatments that are more forgiving to or less than the optimally clean parts?
That is always the case, and I'm sure many companies like us are looking into that. At this point in time, I would say the answer is no, because of the weaker acid, the hydrofluorozirconic acid, that's the primary component pretty much being used in any zirconium pretreatment. It does not do the heavier etching compared to the conventional one. And except adding, which I could certainly elaborate, Kevin. This is not a non-commercial or any proprietary. You could certainly add a surfactant in to the zirconium pretreatment that has been tested out in the marketplace by us as well as many others to increase or to let's call if there is a compromise in the cleaning in the first stage. By adding the surfactant, it can certainly help. It remains to be tested in a full commercial high-end pretreatment at this point in time.
Okay. Did you say that the zirconium risers need to be stainless steel? If so, why?
No, not zirconium risers. I am talking about the stainless steel tank material of constructions. The risers are always that is PVC or CPVC or polypropylene. If I misspoke, my apology, but it's the body of the tank. That is what I was referring to in terms of the stainless steel construction.
How important is the coating thickness for the zirconium pretreat coatings?
From our experience and from our lab study, not as much compared to the iron and zinc. I guess that's where the question come in. In iron and zinc phosphate, absolutely. It's a linear relationship. Higher the coating weight up to a certain degree, higher the performance you would expect in the conventional iron and zinc phosphate. Based on our testing and running the lines, measuring the zirconium active points, zirconium only within that range min to max, we are seeing very minimal at best impact on the overall performance of it.
Okay. What are the effects of zirconium on the human body or operator, or what PPEs are needed?
Okay, excellent question again. Excellent. And I think Kevin and a PCI, something we should consider in the future is to have at least one slide on the PPE side of it, because we talk about chemistry, which is of course near and dear to my heart and you guys' heart as well. It's absolutely important to make sure that we run the process safely, we all go home safely. And we always recommend that prior to putting or touching any chemistry, you are being fully trained by the chemical suppliers. You are fully trained on. Now to come to the answer here, zirconium is as safe as other acids are. They are not carcinogen. We have not heard about any severe, serious injuries related to the zirconium pretreatment. Yes, it's running at a pH of 4, 4.5, 4.8, 5.2. So it's on the acid side of it. We always recommend proper PPE based on the SDS of the pretreatment that you would be using.
Okay. Has it been used for wastewater applications as a scale inhibitor?
I am not so sure. Can you please repeat the question, Kevin?
Has it been used as a wastewater application as a scale inhibitor?
I am not aware that it is being used as a scale inhibitor in the wastewater application. We are not using it. We are not promoting it that way, and I don't have a data on it.
Is there a one-step zirconium cleaner blend for spray wand application?
One step, I'm assuming somebody is referring to the cleaner coater version. Can you verify that, Kevin? If
No,
that
that's the question that was asked.
Okay. If you are talking about a cleaner coater version of zirconium, yes, it's available in the marketplace.
Can
But you have to rinse it. When you say single step, I am assuming that they would like to remove, sort of like not use the cleaner step, Kevin, or the rinse step. They are talking about just a cleaner coater followed by the rinse. There is no pretreatment zirconium by itself, which is a single step that is manual. There is a single step pretreatment that I have heard of. I'm afraid that it is not designed for what we are talking about, which is the industrial application. Because otherwise, then we are trying to put 10-pound stuff in 1-pound bag. And it is being commercialized that way. But I have not heard that there is a zirconium base that can be used only as a single step.
Okay. Can zirconium-based treatment be used for aluminum extrusions that will be able to achieve the AMA 2605 requirement?
It's not only zirconium. There are other elements, proprietary elements within the formulation that are being formulated, which we and other friends also out there promoting as a non-chrome pretreatment for aluminum that meets the AMA specification.
Can zirconium be used on stainless steel parts?
It can be used, but I'm afraid you do not do any sorts of conversion coating on stainless steel. There is no iron that would allow us to do any kind of conventional or the zirconium type pretreatment. If you are talking about just passivating the surface, you can certainly. It's not been tested, but then you are pretty much, I would say you are wasting your money there. If you are talking about simple passivation or etching the surface, you might as well use some other technologies out there in the marketplace to etch and improve the paint adhesion of the stainless steel surface prior to painting.
Okay. What is the ideal pH for the maximum coating thickness? And that might vary on a...
Yeah, I would say our operating range, and again, depends upon the process, but ideal range that we would recommend is from 4.2 to 5. No more than 5.2, no less than 3.8.
Okay. What is the relationship between zirconium and titanium in advanced pretreatment chemistry? Is one versus the other or combination better?
Laboratory testing suggests that zirconium and copper has provided, copper, not titanium, copper has provided a better performance than zirconium and a titanium.
All right, and I don't know if you would be able to answer this because it may vary, but how many minutes of wash per bath for the zirconium application?
Let's call an average 45 seconds dwell time. I think that is what the question is, correct, Kevin?
I just read what was written. I can't know for sure, but I think that's what it was.
Yeah, if you're talking about the dwell time or how much time you would need to apply the parts with the zirconium pretreatment, average 45 seconds. Can some people run at 30, 35? They are. Some people running at 1 minute. Yeah. If you are running longer, you want to sort of use a less concentration. If you have 30 seconds, you want to run on a high end of the concentration of the zirconium.
Okay. All right. Well, we're coming up to our time period. There are a few other questions that we did not get answered here. I would ask those that had a question that did not get answered, just take Suresh's email address there, send him an email, and he will be happy to answer any of those questions, or if someone comes up with a question afterwards. At this point, I would like to thank you, Suresh, for taking the time. And I'd like to thank everybody else for attending this webinar. Please watch for the link to the survey and take a few moments to give us your feedback. Also, don't forget that the new date for Powder Coating Week 2021 in Orlando has been changed to April 27th to 30th. Register now at conference.powdercoating.org. And I'd just like to wish everybody to have a great rest of your day and happy holidays. Thank you.
Happy holidays. Thank you, Kevin. Thank you, everyone. Take care.